Hello everyone, welcome back, and resuming from the last video, we will be building the CNN architecture. The CNN architecture consists of convolutional layers and fully connected layers. And building the CNN architecture is to stack these layers, and usually you apply convolutional layers, and for the last hidden layers, you apply fully connected layers. So in Keras, it provides conv2d to operate convolutional layers. So let's try um, convolutional layers using Keras layers. So we gotta apply from Keras the layers, import conv2d, and for fully connected layers, we need to import dense. And additionally, we also need activation function and max pooling to dimension. So to build the layers, we need to declare the module, and because CNN is a feed for the network, we need to declare sequential module. Sequential, and let's check whether it is running well by running the code. And no module named Keras.layer, and here is the spelling mistake. You need to add s. It's Keras.layers, and run again. And import error, cannot import name max pooling. I guess it's uppercase. So let's run again. And this time name error, name sequential is not defined, and sequential is in from Keras the models import sequential. So let's run again, and this time it's working fine. And type clear to remove earlier process. And for convolutional layer, you can write model that add conv2d, and note that there are three arguments that you need to pass to the input layer of the CNN module, which is the number of filters and the size of the kernel, which is also called as filter, and for the input layer, the input shape. And I won't go into much details of the operation process, and to build a model and see the training process, you can just type following me. So let's keep going, and let's for the first argument, the number of filters, let's pass 32, and let's set the kernel size to 5 by 5 in this example, and the input shape will be, because the image is 50 by 3, the input images. So let's just check. Okay, once again, you can type exit, and if you type exit, then the program is going to stop here and won't process the following lines. So let's check the shape, and because you have 50 by 3, so the input shape should be 50 by 3. And let's pass 50 by 50 by 3 for the input shape, and remove exit, and let's run this code again to check there is no mistake, and it's run fine. And now for convolutional layer, you need to add activation layer model that add activation, and let's apply relu activation, and then let's build the second hidden layer. So you need to type as similar to the first hidden layer model that add comp to D, and this time let's set the number of filters to 64. And for deciding the number of filters, usually when you add layers, the number of filters are doubled. So, and then for the kernel size, let's set it to 55 by 5, same as the first hidden layer. And because this is the second hidden layer, you do not need the input shape, because you already know that how the earlier hidden layer looks like. Let's run again and see that it's running fine, and let's add relu again. And for the second hidden layer, let's add maxpling model that add maxpling 2D, and you need to pass the shape of the filter to the maxpling 2D function. And let's run, and it's running fine. And if you let's add fully connected layers. So what we gotta do is that we need to flatten the layer. So before we go on, let's print the summary of the model. You can see the summary of the model by typing model.summary. And if you look at the summary, so the input image 50 by 50 by 3 is reduced to 46 by 46 by 32, and then passed by passing through the second hidden layer, which is named as comp2d underscore 11, then it is reduced to 42 by 64. And then through maxpling, it's of shape 21 by 21 by 64. So by applying 2 by 2, you can assume that the earlier hidden layer is divided by 2. So because the fully connected layer, you can apply it for one-dimensional layer. So you need to flatten. So to flatten the model, you can apply dense layer. So let's add dense layer after the second hidden layer. So model.add and type dense, and you can choose the number of neurons. So let's type 10,000, and before applying dense, you need to flatten the model. So let's type model.add, and let's import flatten as well. So model.add and flatten, and let's check the summary of the model. So this time you can see that it's flattened and having 28,224, and it's the by multiplying 21 by 21 by 64. So it is reached to 1000 dimensions by applying fully connected layer. And to classify, you need to apply softmax model that add activation softmax. And let's check the model summary again. So this is we have built our CNN model and we need to compile this model. So what we gotta do is that let's compile, and to compile you need to pass the optimizer and model.compile. For the optimizer, let's pass Adam, and for the metrics, let's print out accuracy. So let's see that you can see it's all compiled well, and it's clear to remove earlier results. And then to train, you need to type model.fit, and here you pass the training data. So your input image, you pass it as the first argument to the model, and then to check, you pass train y. This is the label, and during the training process, the model is going to match the output to the labels stored in train y, and to set to the number of layers, let's you need to reduce the model to 7 dimensions. Model that add dense, not 7 because there are 2 categories. You need to reduce it to 2, and there is a loss function you need to pass to compile the model, and this loss function is calculates how far the predicted value is from the true label. So when there are 2 categories, in this case we are doing binary classification because we are trying to predict whether the image is dog or cat. So for binary classification, you apply binary cross entropy. So going to training process, model.fit, train x, train y, and then you need to choose how many times you are going to train this model. Let's set the iterations to maybe 15. Let's train 15 times, and you call it epochs. And then for batch size, let's set it to maybe 10 here. And batch size is the number of training set that you want to train for one epoch. And let's see how it goes by running, and you can see that the training process is starting. And let's wait a bit because it seems to finish quickly. So during the training process, what it does is that it tries to calculate the weights of the filter. So uh, after the model is trained, then you can load the model and use the weights to predict new examples. So if you look at the accuracy, it's 57. So the accuracy is not very good because this model is not optimized. Let's go to the preprocessed.py, and if you see get trained data function, then you see here the normalization processing, and let's apply it to these training images. And the reason we apply normalization is that what deep learning models does is that it tries to find the distributions from the input images, and if the distribution range is large, then it is very hard to find the distribution. And if it ranges in a small range, then it's easier to find the distribution, and the model can converge faster during the training process. So because the input image, the number of pixels in input image ranges from 0 to 255, to set it to scale from 0 to 1, you can divide it by 255.0. And the reason we divide it with floating point is that because it needed to be differentiated during the gradient process. So let's run again. And before we run, let's go to main.py, and we need to save the model. So if you go to the main file where it is stored, if you go to the directory where your main file is stored, then there currently the model is not saved, and this time we are going to save the model, and the saved model is going to be stored in the designated directory. So to store the model, you can do model save. Let's name it as saved model .h5, and let's run again. So the training process has started, and after normalization you can see that the accuracy is higher compared to the earlier training process. It is almost reaching 100%, 97%, and it's almost done. And this time let's check the directory. So in this directory, this model saved model should have been saved, but it's not. Cannot see it here. Um, Till the module is not saved in this directory, so I think you need to pass the full directory path to the module.save. So you copy the destination directory and paste it here, and then write \. So the full directory is C drive prog and the name of the module to be saved. In my case, save the module.h5. So let's check and run again. Press this arrow sign, and let's wait a bit, And let's look at the directory. Now it's epoch 10. So once the training process is finished, you can see that the model is saved, and which is saved in saved model.h5. So up to here, we've covered how to train the machine learning model, and we have built CNN architecture. So in the next video, you'll be deploying this model to predict the images. So the model is trained with images in train set with these images. And what we are going to do in the next video is that we are going to, let's go back to the earlier directory, and we are going to detect the images, whether this image is on cat or dog, by using our trained model. So thanks for listening, and see you in the next video. Bye.